Hello friends, today's question. A block kept on a rough inclined plane as shown in figure remains at rest up to a maximum force 2 Newton down the inclined plane. The maximum external force up the inclined plane that does not move the block is 10 Newton. The coefficient of static friction between the block and plane is. So we are supposed to find out the coefficient of static friction between the block and plane. So this we are going to divide this question into two parts. When only 2 Newton is acting downward, and the second part when only 10 Newton is acting upward. You can say when force, let us suppose that is F1, which is 2 Newton, is acting downward. Inclined plane. So let us draw the free body diagram for that, which includes all the forces. So this is 30, and we have, let us suppose this is M. So we are going to have mg, and this mg is going to have two components. This angle is, let us suppose, theta. Let us consider theta, where theta is 30, and we get mg cos of theta, and we have this mg sin of theta. There will be normal, and frictional force Fr will be acting upward direction. So the block will remain at rest. Downward force, that is mg sin theta. Yeah, I forgot to mention 2 Newton also. This is F1, which is 2 Newton. Okay. So downward force, which is 2 plus mg sin theta, is equal to upward force, which will be equal to Fr, and Fr is mu to n. N is given as mg cos theta, so we get mg cos theta. So we can write this equation as 2 plus mg sin theta is equal to mu mg cos theta. Let us call this equation 1. And for the second case, when force, let us suppose that is F2, that is 10 Newton, is acting up the inclined plane. So let us draw its free body diagram. This is mass m. We have mg, single is theta, we have mg cos of theta and mg sin of theta, and force F2, which is 10 Newton, is acting up the inclined plane, and there will be normal n. So there is a frictional force Fr which will be acting down the inclined plane. Okay, and value of Fr will be same for both the cases. Okay. So we can write here Fr is equal to mu n, which is equal to mu mg cos of theta. Now in this case, you can say the equation will be coming as 10 is equal to mg sin of theta and plus Fr we substitute the value of Fr, we get 10 is equal to mg sine of theta plus mu mg cos of theta. Question number 2. So let us solve these two equations. So using equation 1 and 2, using equation 1 and 2, we get, so let me write these two equations once again. So we are having 2 plus mg sine theta is equal to mu mg cos theta, and second equation was 10 is equal to mg sine theta plus mu mg cos theta. And if we subtract them, these two terms cancel out, so we get this as 2 plus mg sine theta minus 10 is equal to minus mg sine of theta, and with this gives us minus of 8 is equal to minus 2 mg sine of theta. From here you can say that our mg sine theta is equal to 4. Let this be equation number 3. Now we are going to use this equation and substitute in equation number 2. Using equation 3 in equation 2, we get, now the equation 2 was our 10 is equal to mg sine theta plus mu mg cos theta. Mg sine theta is 4, so this is 4 plus mu mg cos of theta. From here we can calculate that mu mg cos of theta is equal to 6. Let this be equation number 4. Now we divide equation 3 by equation 4. Dividing equation 3 by equation 4, we get mg sine theta divided by mu mg cos theta is equal to 4 by 6. So this will be coming as 2 by 3. Mass cancels out, g also, so we get this as tangent of theta divided by mu is equal to 2 by 3. From here we can say mu is equal to 3 by 2 tangent of theta, but value of theta is our 30. So from here we can say mu is equal to 3 by 2 tangent of 30, and tan 30 is root 3 by 2, so we get root 3, sorry, is 1 by root 3. We rationalize it, root 3 divided by root 3. Okay. So these two terms cancel out, so we get mu is equal to root 3 by 2. So we can say this is the coefficient of friction, this is the coefficient of friction between the block and inclined plane. So this completes the question. Thank you.